Things that you have to remember for the cosine and the sine law is that the sine law cannot be used when you have a triangle with a contained angle. So if you have your angle here is 30 degrees and this is 7 and 5, if you only know these two sides and this angle, you cannot use the sine law because you need to have either this side or this angle to use the sine law. So when you have a contained angle, you need to use the cosine law. If you're using the cosine law, you cannot use the cosine law to find an angle if you don't know all three sides. So before you can use the cosine law, you first need to find your missing side to find the angles. So if we take the example 1, a retaining wall is leaning at an angle of 70 degrees to the horizontal. So we can draw that. Here's the horizontal, and a retaining wall is leaning 70 degrees. A rigid support is to be placed 5 meters from the base of the wall. So it's going to be placed over here at 5 meters. And it's going to be attached at the wall 2.5 meters from the base. So it's going to be attached. This is going to be 2.5 meters. And here's our brace. Oops. So here's our triangle. Let's label it A, B, and C. Determine the length of the support, so that's going to be side B, to the nearest tenth of a meter, and the measure of the angle between the support and the wall. So the support and the wall is right here. So we want to find angle A to the nearest degree. So because this angle is contained, we have to use the cosine law first. So we're going to use the cosine law to find the last side. So we want to find B squared. So B squared is going to be equal to our sides squared, so 2.5 squared plus 5 squared minus 2 times 2.5 times 5 cos of B, which is 70 degrees. So B is going to be equal to the square root of 2.5 squared plus 5 squared minus 2 times 2.5 times 5 cos of 70. Type this all into your calculator, and to the nearest tenth of a meter, we get 4.8 meters. Now, we want to find angle A. And because we're using the cosine and the sine law, we're going to use the sine law to find A because it's quickest. So we want to find the sine of A over 5 is equal to the sine of 70 over 4.8 times both sides by 5. A is going to be equal to the sine to the negative 1 of 5 sine 70 divided by 4.8. Type this into your calculator and we get 80 degrees. So the length of our support is 4.8 meters, and the degree between the wall and the support is 80 degrees. So it's best when you have a word problem like this to try to draw the picture first so that you have an idea of what you're looking for. Before we do the next example, we should go over what a bearing means. So bearing is in your directions, and it means you're going to start measuring from 0 degrees. So measure from 0 degrees, which is your north point. So north is equal to 0 degrees or 360 if you take a full circle. East is 90 degrees. South is 180 degrees, and west is equal to 270 degrees. So if you look at a compass, north, south, east, and west, this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. So if you were going a bearing of 150 degrees, you'd start from 0 and go to 150 degrees. So if we're solving problems that involve more than one triangle, it's best to draw a diagram first. Make sure you know what you're trying to solve, and then apply the cosine and the sine laws according to what your situation is. So, for example 2, a communication tower is 35 meters tall. Okay, so you have a tower, and it's 35 meters tall. David is due north of the tower and measures the angle of elevation to the top of the tower as 70 degrees. Let's say that this is north. So this is David, and he is north, and he's measuring the angle of elevation for where he's standing to the top of the building. That's going to be 70 degrees. Brenda is on a bearing of 175 degrees from the tower. So we're here, it's north. We go 175. So this is our 175 degree angle. And this is going to be Brenda over here. And she's looking at the tower with an angle of elevation of 50. So here's Brenda over here. And this is 50. We want to determine to the nearest meter the distance between Brenda and David. So we're looking for this side right here. So in order to do this, we know that this angle right here is 90, and this one right here is 90. We want to find the length of David to the tower and Brenda to the tower, and then we'll have the triangle B and D. Let's call the bottom of the tower T, or S, and the top of the tower T. So we have T equals top, S equals base, so the base of the tower, B equals Brenda, D equals David. So we want to find in triangle BSD, we want to find the length of BD. So first we're going to find DS, then we're going to find BS, and then we're going to find side BD. So first, if we look at DS, we have a triangle like this, a 90-degree triangle, 70 degrees, 35, and we want to find X. So we're going to use our tangent ratio, so tan of 70 degrees is equal to 35 over X. So X is equal to 35 divided by tan of 70 degrees. So we type this out, and X equals 12.74 meters. So we know that this is 12.74. If we look at triangle with Brenda, we have a right triangle again. And we know this degree is 50, and this is 35, so we want to find Y. So tan of 50 degrees is equal to 35 over Y. Y is equal to 35 divided by tan of 50. So Y equals 29.37. So now we have both sides of the triangle BSD. So we know this is 175, this is 12.74, and this is 29.37. We want to find side BD, so this is our little s. So s squared, because the angles contained, we're going to use the cosine law. S squared is equal to 12.74 squared plus 29.37 squared minus 2 times 12.74 times 29.37 cos of 175. So S will equal the square root of 12.74 squared plus 29.37 squared minus 2 times 12.74 times 29.37 cos of 175. Type this all into your calculator, and you should get S to be equal to 42.07. So to the nearest meter, Brenda and David are 42 meters apart.